Hi, today's lesson is about molecular models and what the shape of a molecule actually looks like, and that's also known as VSEPR theory. I'll elaborate on what those letters stand for as we work our way through this introductory lecture. Last class, we learned that Lewis structures are used to help visualize bonds. Lewis structures are used to help visualize bonds. We know that there are three kinds of bonds: metallic, ionic, and covalent, and we learned how to do these Lewis structures for ionic and covalent compounds. The ionic has to show the transfer of valence electrons between two atoms, usually a metal and a nonmetal. However, we may also have the presence of a polyatomic ion. Polyatomic meaning more than one atom collectively having a charge, because that's what an ion is. In the Lewis structure for a covalent, we're showing shared valence electrons, and that is occurring between nonmetals. But we have to double check and make sure that the nonmetals are not part of a polyatomic ion, in the sense that as soon as you get the ion, bing, 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 you know you're going to have an ionic bond. However, they do hold the polyatomic ion together. I hope I made that clear. So for example, hydroxide. Technically, this cluster of oxygen and hydrogen are forming an ionic bond. But what's holding the oxygen and hydrogen atom together is a covalent bond. Let's look at water, for example. I believe we did this in our last lesson. We know I have nonmetals, and as a result, want to show how these three atoms are sharing their electrons. We learned that the oxygen, because it's the piece with the most bonding sites, that's the one I'll start with. And then I'm going to wind up clicking in the other atoms to where oxygen has a lone electron, which is referred to as a bonding site. So to clean that up, I'm showing that water's Lewis structure looks like this. However, when you look at your drawing, perhaps you drew it like this, meaning the atoms are all arranged in a line. Whereas the way I did it right now, they're lined up at a 90-degree angle to each other. Well, how can that be? Right? If I have a glass of water, those water molecules should all be identical. They should either all be lined up in a line, or they should all be at a 90-degree angle. Well, in reality, yes, they are all identical, and no, they don't line up in a 180-degree angle, nor do they line up in a 90-degree angle. And that's what the purpose of today's theory is. Even though Lewis structures are showing us how the electrons are shared, the Lewis structures have a limitation. The Lewis structures do not show us the shape of the molecule. The Lewis structures do not show the shape of the molecules. In other words, they don't show the actual arrangement of the atoms. So in comes our VSEPR theory. VSEPR. And yes, it is pronounced VSEPR. The VSEPR theory says when you look at water, for example, those valence shell electrons on the central atom are going to wind up, those pairs, I should say, on the central atom are going to wind up repelling each other. And we call it repulsion. Theory. And that's where we come up with VSEPR. It stands for valence shell electron pair repulsion theory, or pairs. For example, oxygen, when we look, it has 2 pairs of electron pairs, and those are going to wind up repelling. They're going to repel so that this 180-degree alignment is not so. But the 90-degree angle alignment winds up being too close together. Ultimately, the bonds / electron pairs on the central atom will determine the molecular shape. And you are going to work on a simulation to help you see how, whether it's a bond on the central atom versus a lone pair of electrons on the central atom, are going to influence the shape of the molecule. So at this point, you need to go to the PhET activity, which is dropped into our Google Classroom. And you'll work through the activity to learn about the different shapes. And a concluding question at the end will be to kind of put it all together. Start by drawing the Lewis structures. Do it for ionics, do it for covalence. And it's only for the covalence that our VSEPR theory will be applicable. So once you've got the Lewis structure down pat, whether you've drawn water, for example, linear, or whether you've drawn it at a 90-degree angle, both of those are acceptable for Lewis dot structures. But that's not really what a water molecule looks like. You also need to know that in real life, it's bent in its shape. And you'll learn about that in the PhET activity. Thanks for listening, and have fun with the activity.